I hope everybody is ready for a scientific fairy tale. Our next speaker is Dzmitry, and he will celebrate his 20th year at Swansea Tribology this year, racking up almost 2 decades of experience monitoring lubricant and asset condition. Dzmitry holds a PhD in mechanical engineering, which allows him to see all angles of the asset life cycle while supporting his customers with their oil analysis programs. Dzmitry oversees the laboratory operations at Swansea Tribology Services and will today open our eyes to fantastic contaminants and how to find them. Dzmitry, I can't wait for this any longer. Thank you for joining us. We can see your presentation and I will hand over to you now.
Thank you, Jade. So, why do we want to talk about contamination? Because it can cause problems in our lubricants and therefore in our machines. So, what are some of the issues that contamination can do? It can stop the oil from performing its key function. Adam spoke about viscosity, how important it is. Many contaminants are actually affecting the fluid, the bulk of the fluid. You can have fuel ingress, water ingress, ingress of a different lubricant with a different viscosity grade, and that can lead to a change in viscosity, and it can stop the lubricant from performing its key function. And there are other functions that can be affected, things like demossability, ability for lubricant to separate from water, air release. There'll be issues with corrosion control, hydraulic performance, temperature control. Contaminants can corrode components, and a lot of the times when we talk about contaminants, we also mean particles, where debris becomes a contaminant itself once it's generated. So those can act as an abrasive medium, increasing wear. And contamination can also cause filter blockages, which can then cause oil to go through bypass and just cause all sorts of problems. And generally, a lot of machine failure is caused by poor lubrication, and contamination is a significant contributor to poor lubrication. So I'll speak about how we might want to look at contaminants. So by maybe categorizing them in different ways, and each of those will give us a different perspective. How we can detect contamination using a lab to identify the contaminants, what some of the test methods that may be used, and give a few case studies, a few examples. Generally, it's a bit like CSI, but unlike on TV, we're grounded in reality. So we may need to use different test methods for different types of contaminants, and we have to deal with the quantity of material available and the cost of analysis. So if we split the contaminants by phase, so one of the main phases is the solids. So we have sand and grit particles, wear debris is generated within the machine, but it becomes a contaminant immediately after that and can cause further wear. Things like rust, soot in engine oils, paint chips coming off the different surfaces within the equipment, maybe the painted surface of a tank. Various process materials, powders, fibers, either environmental or from filter media breaking down. You can have degraded elastomers, hoses and seals, and oil itself as it degrades. It forms degradation products, varnish precursors. They may be soluble to start with, but they form insoluble particles which can deposit as varnish and lacquer, can block filters and so on, and they become another contaminant within the system. Looking at liquids, one of the most common contaminants is water, but you also have things like fuel, coolant, AdBlue, using an incorrect lubricant, topping up with an incorrect lubricant, that's a contaminant as well. And when we get the first sample, if the lubricant grade is unknown, then the oil that's already in the system may effectively be a contaminant because it may not be performing its rightful function and may need to be replaced. But also process fluids and maybe detergents used to clean the area and then getting into the system. You also have gases, things like air, refrigerants, so compressor oils so have a lot of refrigerant gases coming in, maybe fuel, steam, vapor. Yes, it condenses once in the oil, but it's a gas sort of coming in, and then various process gases. So whatever it is that you may be compressing, you'll be using your compressors can be getting into the compressor oil and causing issues. So we can also break contaminants down by chemistry. So we look at organic contaminants, so various fluids, oils, fuels, various process fluids. We're dealing with hydrocarbons, they are organic products. Grease, fibers from filter media, sort of cellulose fiber or organic material, various plastic or elastomer debris from O-rings and seals and hoses, and organic in a different way, but biological contamination. So when we're looking at diesel fuel, for example, we can get diesel bug, but also that's something that can come into lubricants, especially when there's a lot of water present, and that can cause problems because there will be sludges and sort of contamination that can clog up filters as well. Inorganic contaminants, so a lot of it is particles, sand, grit, wear debris, various process dusts, other inorganic debris. And we can look at aqueous contaminant as being sort of a separate class on its own. So water, coolants, AdBlue again, various detergents like screen washing and vehicle application, various water-based process fluids. And all of those different chemistries require different approaches, different techniques to detect them and identify them. We can look at contaminants by origin. Is it something that's coming from within the system, be it wear debris, breakdown of like hoses, oil itself, breaking down the degradation product from oil. It could be external, things like water, fuel, coolant, dust, dirt. Adding an incorrect lubricant, it becomes a contaminant. And another way to look at contaminant is by concentration. Is it bulk contamination? You know, we have 10% fuel in this oil. Is it a mixture of different lubricants? We have 50% on one lubricant, 50% of another lubricant, a lot of water getting in. Or is it, and those are often obvious. There are significant effects on many properties, but also sometimes you can visibly see two layers within the sample, where at the bottom you have maybe a layer of water or a layer of different lubricant that has different densities, so they separate, so things can be obvious. But we sometimes need to look for contaminants which are present in very, very small quantities, concentrations. So trace contamination, this can be wear metals, moisture again. Some systems are very sensitive to water content, so being able to detect it at a very early stage, at very unquantified, very low levels, like we were saying earlier, parts per million rather than percentages, and sometimes even 70 parts per million in an application may be considered too high. But also ingress of additives as an indication for different lubricant getting in, and the varnish precursors as well. They're present in small quantities, but they can cause various problems. We can look at contaminants by rate of ingress. Is it gradual? So normal wear particles, maybe water ingress through condensation, slight coolant leak, the degradation of oil, the buildup of the insolubles, soot buildup, and then ingress of dust and dirt, perhaps through breathers which don't have this filtered breathers on, or it could be rapid. So unknown water contamination event, somebody was pressure washing something and lots of water got in straight away, or there's a head gasket failure in an engine, or somebody just put in correct lubricants top to tap, and immediately we have a bulk change, which is very rapid. Ingress of dust of dirt and dirt in a more rapid way, or severe wear event which generates a lot of wear. And then we can look at it by severity of impact. There is some contamination which is going to have moderate impact, slight impact. So things like normal wear, it will build up. It may start becoming a problem by itself, but it will take time. A moderate fuel dilution, we're detecting a contaminant, but it's not causing a problem yet. It's very gradual ingress of fuel, for example, gradual buildup, or addition of a lubricant that's actually a compatible lubricant can work with a lubricant that's already in the system, and we may detect it and we may decide actually we know that it's okay, or we may perform a compatibility study and confirm that it is okay so that we are sure, and then carry on. But you can have critical impact as well. So severe fuel dilution reduces viscosity, can cause rapid wear of your engine, severe ingress of water or coolant. Again, the lubricant layer is broken down, oil is unable to carry the load between the loaded surfaces, and you can have critical consequences of that. And high quantities of particulates getting in, again, that can act as an abrasive component, causing severe wear and rapid failure. So how might we detect contamination? There may be a known contamination event. Somebody thinks, oh, I may have put the wrong oil in, or we know we have pressure washer. They used a pressure washer in this area. We know water is likely to get in, or there was a leak in the roof, and we know water was pouring down onto our piece of equipment. Maybe visual inspection, either of like through an oil side glass, we can see there's discoloration, we may see there's cloudiness, we may see there's changes in appearance of oil, or we may see contamination on the surface of the equipment, or we may see that actually there was we can see that the hatch to the oil tank is open, and this will likely allow some contamination to get in. There may be operational parameters where you may be monitoring temperature, noise, vibration, pressure, various other performance parameters, and all of that may change, and that change may signify, may be caused by ingress of contamination. You may not always know about it, but it may prompt you to, okay, let's find out what's going on. And then another potential avenue is through routine lubricant analysis. Either the lab has detected contamination directly, for example, ingress of moisture, increase of water content, or we notice the change in property, viscosity, or perhaps the emulsibility, air release, something that can be affected by contamination, and then we may want to investigate and find out what the actual contamination is, but we have detected its presence in an indirect way through a property change. So if you are using a lab to identify the contaminants, often we have customers come to us with one tiny sample of something and say, oh, can you find what the contamination is? Oh, this is the contamination, what is it? And there is no context, there's nothing to compare to. So they come to us sort of when they're desperate and they want to find something out and they have taken some steps. It would be great if they involved us early and spoke to us about, well, what is the best way to investigate this situation? So when you send a sample to the lab talking about contamination, you may give your suspicions, or we think it's that, but remain open-minded and allow the lab to suggest test suites which may do an overall condition. We had a sample come in where a client was wanted to check if there was AdBlue in fuel. We got that fuel sample. Normally fuel is, fairly clear liquid, maybe slightly yellow or slightly red if it's red diesel and so on. It was black. We tested it. They allowed us to perform the standard test package rather than just looking for AdBlue. So for reference, if there is AdBlue contamination in fuel, if it's significant, there's normally a layer of separated fluid at the bottom of the jar, which you can then test and find out if it's water, something else, or if it's AdBlue. There was no separation there. Sample was black. When we performed the routine analysis, we found those trace engine oil additives and a layer of black sealed, likely soot contamination. So it looks like there is engine oil getting into sooty engine oil getting into the fuel, and that's something that the customer can investigate, but it was not in line with the initial assumption of AdBlue. When you perform an investigation, you may want to find out not only what is the contaminant, but also where is it coming from and how is it getting in. So this is where deciding what samples to take, where from, how to take them, you may be able to narrow down the point of ingress for the contaminant. But also, as you're listening to and looking at these presentations, you're in a position where you could afterwards take steps to prepare yourselves for when you may need to identify a contaminant and do some sort of investigation, because you want to have to hand some clean oil sampling bottles rather than a rinsed out coffee jar or a lemonade bottle, cola bottle, and so on, which immediately introduces a question, well, the water content we're finding in the sample, is it contamination of the sample, or is it because you had no suitable oil analysis container available and just used whatever was to hand and you rinsed it and it wasn't dried properly? And then you want to take into account how much sample you're able to provide. You want to collect as much as possible, because different tests looking at different chemistries, for example, may require different quantities of sample, or if you test on certain properties. So another question is, can the sample be isolated? Can you isolate the contaminant, or is it contaminant that's present in a sample of oil or grease or whatever it may be? And then ideally you want to supply, so if you have isolated contaminant, ideally you want to supply a sample of oil, bulk oil from the system, because that will give context. And if you can supply a sample of virgin oil to be used as a reference, or samples of candidate contaminants, if you say, well, we think there may be incorrect oil being put in, these are the lubricants we have on the site, so we can supply you samples of virgin oils of other grades which are present. So discussing then what tests may be used, there are some tests that everybody who is at all familiar with oil analysis will think of straight away and go, oh, can we just get that done? But speak to the lab, describe the problem, ask them if there's anything else they can recommend, and sometimes there may be multiple tests which can help isolate contaminants, narrow down, and confirm whether it's this or something similar, and it's useful to discuss things like that with the lab. Sometimes the lab may be able to prepare a sort of synthetic reference, simulate the contamination. So if you think there's so much of this product getting into this product, if you supply those neat products together, we can mix them and then compare with the sample, the unknown sample, and see, is this similar to that mixture? And if in some situations it's not always possible to fully understand what the contaminant is, you may, however, be able to eliminate a lot of other things and decide and understand that the contaminant is not this. It's not this lubricant, it's not this grease, it's not detergent fluid. You could also use this opportunity to assess the condition of the oil, whether it is still good, whether it's still able to perform its function, even though there is a degree of contamination in it, but the contamination that's present may not affect the key properties. You have detected something, maybe it's a compatible lubricant. You could talk with the lab and decide on further steps of how to continue the investigation. So, as I said, if a lubricant is being added in and is deem the contaminant. In the initial instance where you don't know whether it is going to cause any problems, you could perform a lubricant compatibility study and then determine, yes, actually they are compatible, they are fine to use interchangeably, or we may prefer to stick to one, but if there is a disruption in supply, we're able to use this other lubricant, and it's not a problem. We don't have to immediately drain oil, lose hundreds of liters of oil, and then refill it with a proper lubricant once it's back, because the lubricant that we have is actually acceptable. So moving on to a few tests. Visual appearance and color may be indicative of contamination. Viscosity can help detect fuel dilution, incorrect lubricants, process fluids, degradation of oil, oxidation, for example, cracking. Flash points for detecting fuel, gas, incorrect lubricants sometimes. Density, different lubricants may have different densities, different process fluids and fuel. Water content can be detected directly by Kalfischer titration or crackle hot plate infrared and so on. And then elemental analysis using either ICP or rotating disk electrode, looking for wear metals, additive elements, contaminants. Particle count may help detect ingress of particulates, but it's also useful to separate the more solid contaminants, or sometimes sludges, fibers, and so on, onto a filter membrane for further examination, either microscopic, and you're able to see quite a lot of difference between the different contaminants you have. Some sort of copper-based wear particles, and you have cotton wear particles, you have some fibers from filter media degrading. You can get a lot of information from just looking at the contamination. And you can also then use things like scanning electron microscopy, which is very good at analyzing the elemental composition of individual particles, of particle population. So you can find out that we have 30% of the wear debris is of this metallurgy, which leads to a particular component. 20% is of a different metallurgy, so there's another component that's also wearing. And this works for inorganic contaminants, wear debris, that sort of thing. Another useful method is infrared spectroscopy. This works best for organic compounds. The spectrum that's produced is indicative of molecular bonds present in the sample. When samples are a mixture, it may be possible to isolate the samples and test each component individually. But we also have access to previously tested samples, library spectra, and can also not only identify a contaminant, but we may be able to exclude certain contaminants. So as a case study, we had a customer come in with some fibers that we found in the oil system. They brought us some rags and some spill kit, and we were able to perform sorry, perform analysis and identify that the pad material was a match to the fibers and the other material was not. So they were able to then identify where the contamination is coming from. Another case study, we had suspicion of seal oil getting into the lubricating oil. We performed infrared analysis, some other tests, and they have provided us a sample of virgin oil. And we found that the virgin oil sample that they have provided us was not matching the expected grade. And that's why the viscosity was different. So we use infrared spectroscopy as well to check the contamination, the concentration levels of prepared text mixtures of lubricating and seal oil. We were able to predict it with high degree of accuracy, and we were able to confirm that actually there was no seal oil in the lube oil, and that the fault was entirely due to an incorrect lubricant being used. Another example of detecting contamination through a property change, we had an oil sample where after a long time of good demulsibility performance, we had a sample with poor demulsibility. So instead of demulsifying after 210 seconds, after the 1200 seconds, there was still 5 milliliters there's only 5 milliliters of oil separated. We repeated with follow sample just to check, make sure there's no issues. And the result held. And one of the things we noticed was very low levels of calcium and silicon in the system. And the emulsibility of oil is a property that can be sensitive to very low concentrations of certain contaminants. So this information gives the customer a chance to investigate, find out where the contamination may be coming from. But it's not just about finding out what the contamination is, it's also finding out what you can do to deal with it. And in this situation, whether this property is critical or not, because the emulsibility is important when there is water getting in, but if you have very good controls of moisture levels, no water getting in, you may be able to continue with this condition where the emulsibility is not ideal. So we saw, as I said, a little bit of calcium and a little bit of silicon, which initially did not strike us as particularly high and abnormal, but once the problem was confirmed, we investigated further, and that was a possible cause for the emulsibility problems. And then finally, when a lab is trying to help, they may be able to give you advice not only on what the cause of something is, but sometimes a solution. We have spent some time investigating a situation where some waste oil was turning into a solidified gloop, which could not be used. And then it became very expensive to dispose. Whereas when it stayed liquid, it could actually be used as a supplementary fuel in coke ovens. So we have performed a lot of testing, and we just could not identify what the problem was, whether it was specific contamination, whether it was just a different initial product coming in. There were just too many variables at the time. So with clients, we were able to come up with a solution of adding some waste diesel, degraded diesel that they had available on site, and that allowed the fluid to stay liquid and stopped it from solidifying. And they were able to successfully use it as a supplementary fuel. Thank you, and I think we will be able to take questions as a panel later on.